Lesson 5 looks back to a grade 9 topic, solving inequalities. Our key idea, our goal for today is to be able to solve an inequality, be able to represent the solution, and know the difference between solving an equation and an inequality. And there are two key differences here. So on these ideas right here are the inequalities we're going to focus on. Greater than, less than, greater than or equal to, less than or equal to. We're not going to worry about not equal to. I guess that's the only inequality. What does it mean to solve 2 is less than x, or better, x is greater than 2? When you read an inequality, always read from the letter, and our letter is always going to be x. What it means to solve this is to find the truth. So this seems to be the answer to all my questions this unit. What does it mean? It means to find the truth, and that means find all the values of x that are greater than 2. And here's one of the key differences that makes an equation different than an inequality. There are an infinite amount of answers to this. And in fact, this is how you answer that question. It is impossible to write down all of the values of x greater than 2. You would die before you finish. So mathematically, that's what I've just highlighted. The other way we have to be able to identify the truth is on a number line. And our number lines don't have to be exact. They don't have to have all these little markings on them. What they really have to have is this key point. I call it the critical point. The point where the answer is on the right-hand side of that point, or the answer is on the left-hand side of the point. So notice when I didn't worry about 0, and notice I put the 2 right in the key point, right in the middle of the number line, and this is a good habit to get into. So there's one thing I need to introduce right now. Notice I drew an open dot. And the open dot matches the greater than or less than symbols. An open dot means 2 is not included. So whenever you have less than or greater than, that means 2 is not the truth. 2 is not greater than 2. 2 is equal to 2. When our critical point is a part of the solution, a part of the truth, it's a closed dot, so a solid dot. So this closed dot means including this answer. Now, this is how I would always get in the habit of answering an inequality. I would always write the letter first. And if you write the letter first, so we're always going to use x. If x is written first, meaning on the left, then the inequality points to the answer on the number line. Points the same direction. As, I'll call it a graph, but it's a number, it's the number line. So in this one right here, if we instead of writing 2 is less than x, if we wrote it exactly the same, what you'll notice is this thing is pointing the same direction as that thing. And that's a habit I'd get into. Well, let's look at a really straightforward question. We want to solve this inequality. 3 is less than or equal to x minus 1. And what I want to find is all the values of x that make that true. But remember, there's an infinite amount of answer. So here's what we're always going to do. It doesn't matter what we're doing. system of inequalities, what we're going to do is we're going to treat it like an equation first. We're going to not worry about that inequality. We're going to solve it as an equation, and we're going to find that critical point, that balance point, the point that separates the truth from the non-truth. So in this one right here, we're not going to worry about that inequality right now. We're just simply going to go ahead and solve that. And when we solve that, x is equal to 4. Add 1 to both sides. And again, this is what I call the critical point. And this is the number we're going to plot on our number line. So I'm going to put this number on the number line. And I'm always going to put it in the middle because it really doesn't matter. And if I were going to do my own solutions, I wouldn't have a whole bunch of these dashes. I just have the one right in the middle. Now here's what we're going to do, and I really like this method because you just simply pick a number on each side, and that's why I'm saying check two values for your solution. You pick a number on each side and you see which side makes this true. So in this case right here, I would pick really simple numbers. I would pick numbers that are really easy to do, whether you do them in your head or on a piece of paper, but I'm going to choose 0 and 10. So again, what's going to happen is the truth is going to be on the right-hand side of 4 or the left-hand side of 4. And if we check this value, it can only be on one side. The truth is only on one side of 4. So when I choose the number 0, so here's my 0, what I'm simply going to do is I'm going to plug that number back into the inequality, and I'm going to see if it's true. Does it work? And here's all I mean. Is 3 less than or equal to 0 minus 1? Is 3 less than or equal to -1? And in fact, this is not true. 3 is greater than -1. So this is not true. And automatically, the truth is not here. And if the truth isn't on this side, the truth has to be on the other side. So so it's not true, so the truth is on the other side. Now, if you understood this, you could stop right now and you could draw that graph, or you could write the answer. And we'll write the answer last because our picture will show us the answer. So I'm just going to play for a second, and I'm going to say, well, I'm going to choose 10. I just want to show you that 10 will work out to be true. And we're just checking this inequality. Is 3 less than or equal to 10 minus 1? Is 3 less than or equal to 9? And that's absolutely true. So here's what we know. We know that the truth is over here. And my arrow is going to point that way. And now the only thing I have to do is decide, do I include 4? Is that a part of my solution or not? Is it a closed dot or an open dot? And in this case, it will be a closed dot because our inequality is greater than or equal to. So if I plugged a 4 in there, is 3 less than or equal to 4 minus 1? Is 3 less than or equal to 3? Well, yeah, 3 is equal to 3, so we include it. Now, the really great thing about drawing this picture, as soon as you look at the picture, you write your letter, X, you write your critical point, and then you put in the inequality, and the inequality points in the same direction. So again, you might have learned a different way in grade 9. I really like this way. I think it's really simple, really easy to see. So one of the key differences between solving equation and inequality is there are an infinite amount of answers, not just a dot on a line, if that's what you did in the past. We have to represent it mathematically and graphically. Well, let's have a look at the other interesting thing between differences between inequalities and equations. And let's go ahead and do this and see if you remember it, or see if this makes sense. So again, remember what we said. The first thing we do is we solve the equation. And the equation gives us the critical point. And I'm just going to write this critical point on my graph. And again, it is just in the middle. And I'm going to check two values in the region, and I'm going to pick simple ones. So I'm going to pick 0, and I'm just going to pick -5. It really doesn't matter. So I'm going to go ahead and see if the inequalities are true for -5, or is the inequality true for 0. So I'm going to check -5 first. And I'm just going to plug it in. Is -2 times -5 less than or equal to +6? Is +10 less than or equal to 6? And absolutely, we know the answer is no to that. So given that I know the answer is no, what I could do right now is I know where the answer is. It's not over here, so it has to be over there. But I'm just going to do this one more time just to check. So if I plugged in a 0, and a 0 is always a great one because it's really easy to do. You could do it in your head. I'll write it down. Is -2 times 0 less than or equal to 6? Is 0 less than or equal to 6? And 0 is less than 6, so there we go. So here's what I know. I know my solution region is over there. Doesn't matter what number I pick. I could pick 1,000,000,000 if I wanted to. And now I just have to decide, do I do a solid or an open dot? And again, this one is a solid dot because it is less than or equal to. So look at the original, and so let's write down the solution. So then the solution is x -3 pointing that way greater than or equal to. So here's what I want you to notice. Notice the original question with the x, it was the less than or equal to, and in the solution, it turns out to be greater than or equal to. So I just want to remind you of something, make a little note that you actually don't need to know if you do a checkpoint. So it seems that the inequality is backwards in the answer. So the inequality in the answer is the reverse of the question, or the inequality equation. But it's backwards. But it's important for you to understand that this is the truth. You can't argue with it. It is true. And again, you might have learned a shortcut. When you multiply or divide by a negative number, the inequality gets flipped. And here's the second key idea. But nobody needs to know this key idea, because if you simply find the critical point and you simply choose one test point, if the answer is true, you know you're on the right side of the critical point, and if the answer is not true, you know the answer is on the other side. So here are the two key differences between equations and inequalities. Inequalities have infinite amounts of solutions. So that's why we need those symbols, greater than, less than, etc. And funny things happen. Or funny things can happen with inequality sign, with the inequality sign sometimes. So let's do one last one just to reinforce this idea. So we want to solve this inequality. We want to find all the values of x that make the left-hand side less than the right-hand side. And again, the way we go about this is we don't worry about the inequality. We solve an equation. And again, we subtract 5 from both sides. We add the opposite before we do the opposite. So this is good grade 8 math. And there's our critical point right there. And I'm just going to put that critical point in the middle. And then ideally, we don't have to check 2 points now. We'll only check 1 point. And again, I'm going to pick, it doesn't matter, I'm going to pick 0. 0's over here somewhere, and 10's over here. So I'm going to choose 0. because 0 is really easy to do in my head, but I'm going to write it out anyway. So again, on my 0 choice, I'm going to have -3 times 0 plus 5, and I want to know, is that less than -18? Is 0 plus 5, which is 5, less than -18? And of course, the answer is no. And what that really says is the solution is not on this side of 8, it has to be on the other side. And if you don't believe me, go in and check it again, plug it in for 10, and you'll find that your inequality is then true. And the only thing we have to decide then is, do we include 8 in our solution? And the answer is no, because our inequality is less than, not less than or equal to. So looking at my picture now, I can go ahead and simply answer the question using math, not pictures. And there it is right there. X on the left, arrow pointing to the right, and not including 8. X is greater than 8. Any number greater than 8 will make that inequality true.